Hey, this is Math 6, Unit 3, Lesson 6, Interpreting Rates. So we're going to explore some rates, unit rates today. So we've been kind of building towards this, so here we go. First of all, it says something per something. Think of two things you've heard described in terms of something per something. Can you think of something that you've heard along those lines where it's talking about something per something? Maybe something along the lines of miles per hour. Right? That could be something there that you may have heard of before. So those are the kind of things we're talking about as we're looking at today's lesson. So something per something, things that you've heard before. All right? So that's what we're talking about. Miles per hour. Maybe you talked about price per pound. You know, if you're going to the grocery store, you know, to buy something, maybe you're buying some apples, and so it's how much they cost per pound. Those are the kind of things we're talking about there when we're talking about a something per something. So maybe think of some more ideas with your classmates and see what you can come up with. All right, activity number 2. It's called cooking oatmeal. So this really gets us into today's lesson. And so what we want to talk about is how we need to be a little bit flexible when selecting what we call a unit rate. Sometimes we want to always kind of pick maybe the hour as the unit rate, but sometimes we could do how many hours per mile. That doesn't make a lot of sense, but it doesn't make a difference really, is what we're going to look at today. That we need to be flexible in what we call the unit rate. It's because when we look at these different terms, we have a term A and we have a B, which we've been setting up as a ratio all along. But A and B can be written as A over B to make one unit rate, but it can also be written as B over A. Yes, it means something different, but they both are acceptable, and depending on the context of the problem, one might be a better unit rate to use than another one. And so we're going to look at some examples of that today to really kind of see how that takes place and why sometimes it's better to use one over the other. Okay? So here we have Priya, Han, and Lynn, and Diego are all on a camping trip with their families. The first morning, Priya and Han make oatmeal for the group. The instructions for a large batch say, bring 15 cups of water to a boil, and then add 6 cups of oats. So Priya says the ratio of cups of oats to cups of water, so oats to water, she says, is 6 to 15. 6 to 15. That's 0.4 cups of oats per water. So 0.4 cups of oats per 1 water is what she's saying. Han says the ratio of cups of water to oats, so water to oats, is 15 to 6. That's 2.5 cups of water to 1 cup of oats. So they're both saying something similar, but yet a little different, right? In terms of the unit rate, this is 1 unit of water in Priya's example, and Han is saying it's 1 unit of oats in his example. Their numbers are the same, but the order is a little different, right? Oats is here for 6, oats is here for 6, water 15, water 15. So what they're doing is they're writing a different version of A and B. In one, it's A, B this way, and the other one, it's B to A. So they're saying similar things in a different way, and the question is, who is correct? And explain your reasoning. And that's really what we're talking about today in this lesson. So we use our table, and we have 15 cups of water and 6 cups of oats. And we can see that, first of all, in this side, we're going to go ahead and do what we've done before, and we're going to turn that 15 into a 1. And the way we've done that is by multiplying by 1/15. 15 times 1 times 15 times 1 or 15 gives you 1. We know that then we could find out in terms of oats what that oats value is going to be, because we're going to make an equivalent ratio here. So to do that, that becomes, I'm going to write it in the box here, that becomes 6 times 1 over 15, right? Because I'm multiplying by a 1 over 15 right there. So 6 over 15 is 6 over 15 like this, and I can reduce that. 3 goes into here 2 times, and 3 goes into here 5 times. So I have 2/5 right there. Well, 2/5 is a fraction, obviously, but 2/5 is the same as 0.4. Okay, and you can use a calculator to find that out there. So whenever I have 1 cup, if my unit rate here is 1 of water, here's 1 of water right there, how many cups of oats would I need? 0.4, which is what Priya was saying. I need 0.4 cups of oats when I have a unit rate of 1 water. So she's correct. That is true so far. But let's take a look at what Han was saying, because Han was saying, let's make oats our unit rate. Let's make that our unit rate. So to go from 6, on this case here, 6 to 1, that's multiplying by 1 over 6. So let's do that here with the 15. Okay, so we're going to do 15 times 1 over 6. That becomes 15 over 6, and 6 goes into 15 2 times, and that's 12. 15 minus 12 is 3, so we have 3 over 6. So I end up with 2 and 3/6, or 2.5, or written as a decimal, 2.5. Well, what do we notice? That when we use 1 cup of oats as our unit rate, in terms of how much water we need, it's 2.5 cups. So both of them are actually correct. It just depends upon which one do you want to call your unit rate, and then from that you make your other equations or your other measurements. So if you want to call your water unit rate, then you can make the oats the one that's the decimal or fraction. If you want to make the oats the unit rate, then you make the water the other one. So it just depends on what you're working with there. And sometimes, as we'll see, one option is better than another. Okay? So that's the idea. So these are both unit rates, and the key here is that we're being flexible, learning to say, hey, I can do A over B or B over A and make one of them the unit rate, and it doesn't matter which one as long as I'm consistent and know what I'm talking about. It then says, in the next weekend after the camping trip, Lynn and Diego each decided to cook a large batch of oatmeal to have breakfast ready for the whole week. Okay, I don't know if I'd make breakfast oatmeal and make it last the whole week. That might get really soggy by day 2, but okay. So Lynn decides to cook 5 cups of oats. How many cups of water should she boil? All right, so we're given, in this case here, we're given oats. That's what we're given, is we're given the oats value. So think about it this way. If I have water and I have oats and I have a table like this, I know that I'm given that I'm going to have 5 oats. So because I'm going to be given 5 oats, I want to use oats as my unit rate. Okay, if I'm given oats, let's make that our unit rate, and that'll be my 1. So when I go back to before, 1 oat was the same as, when I had 1 oat, I would use 2.5 cups of water. Back to my previous table. I just got that from our last one, so I'm not making up a crazy number here. That's from right here, right? 1 oats is 2.5 water. So just transfer that information over there. So I'm going to keep the oats as 1 because that's the information I'm given. I'm given 5 cups of oats, which means I can go from 1 to 5, just simply times 5. And so then I can just do 2.5 times 5, and 2.5 times 5 is 12.5. So I would need 12.5 cups of water to boil for 5 cups of oats. In example B, we have 10 cups of water. So what's given? What's given to me is the water, so let's use the water as the unit rate. So we'll set up our table. Here's water, and here's oats. Water will be my unit rate, and oats, if you recall, was 0.4. The reason I'm doing that is why? Because it's easy to go from 1 cup of water to 10 by just simply multiplying by 10. It's pretty straightforward, right? And then I can multiply this by 10, and 0.4 times 10 is 4. So we'd have 4 cups of water. So my strategy so far has been to use what's been given and then decide that that's going to be, for in this case, our unit rate, and let's set the table up using that as our unit rate and solve for what is missing there. Did you use Priya's rate, 0.4 cups, or Han's rate, 2.5 cups of water, to help answer each of the previous 2 questions? In our situation, we used them both, but it depended upon the situation and what information we were given. Okay? So that's the idea. So both work. You could have solved it the other way too. It just might take a little more time with more computation, but that's the way we did it this time. Let's take a look at the cheesecake, milk, and raffle ticket problem. For each situation, let's find the unit rates. Cheesecake recipe says mix 12 ounces of cream cheese with 15 ounces of sugar. So we have 15 ounces of sugar, 12 ounces of cream cheese. So as a table, and we'll set this up over here, we have cream cheese and we have sugar, right? And so we know what we're doing so far is we're taking what they provide us with, the first ratio, 12 ounces of cream cheese goes with 15 ounces of sugar. I know I want to find a unit rate for cream cheese, and I also want to find a unit rate for sugar, most likely. Because when I look at the problems, it's going to say how many ounces of cream cheese are there for every ounce of sugar. So ounce is 1 ounce of sugar. And over here, how many ounces of sugar is that for every ounce, 1 ounce of cream cheese? So I have two different unit rates I want to find, the unit rate for sugar and the unit rate for cream cheese. So I'm just setting the table up ahead of time so I'm ready to go. Okay, so let's do this here. So to go from 12 to 1 right there, that's going to be times 1 over 12. So this is 1 over 12 times 15. And this in this row here, to do the same thing, 15 over 12 can be 15 over 12, which can be reduced. 15 over 12, 3 goes in there 5 times, and 3 goes in there 4 times. So we have 5/4 on that one. Okay, and then on the next row, we go 15 to 1 becomes multiplied by 1 over 15. So this becomes 12 times 1 over 15. So 12 over 15 is my answer there. It's really small, I know, 12 over 15, which means I end up with 4 over 5. All right, so when I have 1 sugar, how many cups of cream cheese do I have, or ounces do I have? I have 4/5. And when I have 1 cream cheese, how much sugar do I have? I have 5/4. So that's as it is in the fraction. If I want to convert that into a decimal, I certainly could. This would be 0.8 ounces, and this would be 1.25 ounces. And you can use a calculator to figure that out. The key, though, was just taking the initial ratio here and then find the unit rate for each one individually. And that's what we're going to do for the next couple problems as well. So here we go. Let's work on these here. So if you're working on it in class today, and whatever it might be, let's set the table up, maybe press pause and see if you can fill it in, and then check and see how you did. So here's our rate. We have 10 gallons of milk every 6 weeks. So here we go. We have milk and we have weeks. Make our table. We know we have 10, which goes to 6. And then we're going to make 2 lines here, 2 rows. We're going to have a unit rate for milk and a unit rate for the weeks. So the milk one is going to be times what? Times 1/10. So this becomes 6 times 1/10, which is 6 over 10. That reduces, 2 goes in there 3 times, 2 goes in there 5 times to 3/5, or I could also write that as 0.6 for milk. Okay, so when I have the unit rate of 1, I'll get there. We'll come back to the problem in a second. But the next one, to go from 1 to 6, that's times what? That's times 1 over 6. Okay, that's how I get there. So let's do this one here. This would be 1 over 6 times 10. So you end up with 10 over 6, which reduces down to 5 over 3, or 1 2/3. I'll write below here, 1 2/3. Right? Same thing. Notice that once you figure out one, what are you seeing happening with your fraction for the other one? If that's 3/5, what's this one going to be? The reciprocal. We're just flipping it over, right? So once you figure out one, it becomes reciprocal for the other one. Let's go back to our problem. How many gallons of milk does the family drink per week? That per week tells me our unit rate is going to be the week. So the week is 1, so where's the week 1? Here. So how much milk do they drink per week? 1 2/3 gallons. So 1 2/3 gallon per week. The next question, how many weeks does it take for the family to consume 1 gallon of milk? So that's our unit rate. 1 gallon of milk is going to be consumed in how much time? It's going to be consumed in 0.6 or 3/5 of a week, or 0.6 of a week. which means a little more than half a week. I'm not quite sure what 0.6 of a week is, but that's what our answer is going to be. Okay, so the same idea we did before with the cream cheese and sugar, we do now with milk and weeks. One more to do here, just like that. So let's see how this works. We have Tyler paid $16 for 4 raffle tickets. So what do we have? We have dollars, and we have the raffle tickets. So let's write RT. All right, we know we're going to be looking for a per ticket, and we're going to be looking for a per dollar. So let's start with what we know, $16 for 4. $16 for 4. Our first one's a per ticket, so let's make that a 1. So per ticket, that becomes times 1/4. So what is 16 times 1/4? Well, 16 times 1/4 is 16 times 1/4, reduces there to 1 and a 4, $4. So the price per ticket is $4. Are we done? Nope. Now we have to do the price per dollar. Now, notice here I could do a couple things, right? I could do the 16. I could also then just do the 4 if I wanted to. But for the sake of keeping it consistent, let's go ahead and do 16 times 1/16 in order to make this a 1. So 4 times 1/16. So 4 times 1/16 is going to be equal to 1/4. Why? Because it's 4 over 16, which reduces to 1/4. Notice that it is, again, the reciprocal of the other unit rate. That's a 4 and that's a 1/4. So how many tickets is that per dollar? For $1 you can get 1/4 of a ticket. You can't even get a whole ticket for $1. Alright, and that is how that works. Okay, pretty cool. Next one. For each problem, decide which unit rate from the previous situations you prefer to use. So we're going to use them from up above and then solve the problem. So let's see what we have here. If Lynn wants to make extra cheesecake filling, how much cream cheese will she need to mix with 35 ounces of sugar? I'm going to take a look and see what do they give me. They give me, this is my given, they're giving me the sugar. So I'm going to use sugar as my unit rate of 1, and then we're going to do the 35 ounces. This is the number I'm going to work with. So we go back to our sugar problem, and where was sugar equal to 1? Well, sugar was equal to 1 here, which meant our rate was, when sugar was 1, our rate was, let's use the decimal, 0.8. So we're going to take our amount that was given, 35, times 0.8. Why? Because there's 0.8 ounces of cream cheese for every 1 sugar. I'm going to use 35 sugars, so I multiply that out, and we end up with 28 ounces. 28 ounces of cream cheese. So what's given here, that number, I multiply by the unit rate, and we're good. And B, how many weeks will it take for May's family to finish 3 gallons of milk? So we're looking at milks here. We have 3. We're going to use milk as our unit rate of 1, and we'll take the 3, and we're going to multiply it by what was the unit rate when milk was our unit. All right, so when milk was 1, here's milk at 1. Oops, sorry a little bit, sorry. When milk was 1, weeks was what? 0.6. So we come back here, multiply it by 0.6, that becomes 1.8. So how many weeks will it take? It'll take 1.8 weeks to finish 3 gallons of milk. And our last one, how much would all 1,000 raffle tickets cost? So our unit rate's going to be our raffle tickets, because we want to find that unit rate and multiply by 1,000. So we'll take 1,000 raffle tickets and multiply what the unit rate is per raffle ticket. A raffle ticket, when you have 1, is going to be worth $4. So we'll take the 1,000, multiply it by the 4 for $4 each, and it ends up being $4,000 is how much it would cost for all the raffle tickets right there. All right, so that's the idea with today's lesson. Let's take a look at your summary real quick. When we look at the summary, what we see is that suppose a farm lets you pick 2 pounds of blueberries for $5. We could say we could get 2/5 of a pound of blueberries. We could get it per dollar. We can also get blueberries cost $5/2 per pound. There are 2 ways of looking at this because there are 2 unit rates for the situation. And that's what we're talking about today. There's a unit rate for the blueberries of 1 and the dollars for 1 as well. Now, we talked about noticing that when you figure that out, which might come up later on, we do notice that there seems to be a relationship there that these end up being reciprocal numbers, right? So once you figure out one unit rate, the other one tends to be the reciprocal, doesn't it? So for our understanding today, the point is here is that a unit rate tells us how much of one quantity for one of the other. Each of these numbers is useful in the right situation. And the key is knowing which situation to use which number in there. So there's a couple examples, just like our ones in our book. But which unit rate is most useful depends on what question we want to answer. So always be ready to find either one because it just depends on what the question is that you're being asked to answer. I'm going to pause there, give you a moment to work on your homework, and then we'll come back and check it together. Alright, here we go, homework time. The pink paint mixture uses 4 cups of white for every 3 cups of red. So here's our 4 white and our 3 red in our table. The table shows different quantities of red and white paint for the same shade of pink. Complete the table. So because the table is going to be the same shade, that means we're going to be creating equivalent ratios here all the way down. We can see we're going to create a unit rate for 1 red. We're also going to create a unit rate for white as well, and then find some additional values. Alright, so let's start with the first one. To go from a 3 to 1 is multiplying by 1/3. So if we do the 4, we'll do 4 times 1/3, which becomes simply 4/3. And we'll leave it like a fraction for now, we'll leave 4/3. Here, to go from 4 to 1 is multiplying by 1/4. So go to 3 to 1, we multiply by 1/4, and we end up with 3/4. Again, notice that these are what? They are the reciprocal. Now, knowing the unit rate, if I have one of these and I want to have 5 of these ones, 1 to 5, then I could take the 3/4 and multiply it by 5 as well. That's times 5. This is times 5. So we have 3/4 times 5, which becomes 15 over 4. And we can leave it as 15 over 4, or if you wanted to find the decimal, that would be 3.75. And then we have this one, so to find from 1 to 4 right there is times 4. So we'll take 4/3, and we'll do 4/3 times 4 to give us 16 over 3, which we could leave at that, or if you wanted to make it into an improper fraction, that would be 5 1/3, or 5.3333. Okay, so those are my numbers. I have 4/3, 3/4, 16/3, and 15/4. Number 2. A farm lets you pick 3 pints of raspberries for $12. So what do we know? We have price and we have pints. So we can make a table. We know that for $12, I can get 3 pints of raspberries. Got it. What's the cost per pint? Per pint means what? When I have 1 pint. What's the cost when I have 1 pint? This is times 1/3. So this becomes 12 times 1/3. And 12 times 1/3 is 12 over 3, which equals 4. So the cost per pint is $4. How many pints do you get per dollar? So per dollar means, let's take our dollar number and make that 1. Again, I could look at the 12 and do this is 12 times, 1 over 12. And this becomes 3 times 1 over 12, which is just fine. And so 3 times 1 over 12 is 3/12, which reduces to 1 over 4. And so how many pints do you get? You get 1/4 of a pint. At this rate, how many pints can you afford for $20? So here they're giving me the rate, 20. So we're going to put 20 in the dollar category. So to go from 1 to 20 is times 20. So we find our matching row. 1/4 times 20 is 20 over 4, which reduces to 5. So you get 5 pints for $20. At this rate, how much will 8 pints of raspberries cost? So we have 8 pints. We're going to put that over here. So we find my 1. 1 to 8 is times 8. So we take the 4 and we do 4 times the same number, 8 is 32. So how much would 8 pints cost? They would cost $32. So it's just a table, and we're just filling it in, going down the columns, and making sure that our rows keep the equivalent ratios intact as we go along. But we did find those unit rates first, which helped us out with the other two questions. And again, notice our unit rates, we have 4, and the reciprocal 1/4. All right, next one. Han and Tyler are following a polenta recipe that uses 5 cups of water for every 2 cups of cornmeal. Here's what Han says, here's what Tyler says, and the question is, do you agree with either of them? So we're going to see if either of them are right or wrong. Let's make a table and find out. So we have water, and we have cornmeal. We have 5 cups of water, we'll go with 2 cups of cornmeal. Right? So let's first of all find our unit rate. Let's find our unit rate for water. So 5 to 1 is going to be multiplied by 1/5, right? Times 1/5. So 2 times 1/5 is going to be 2 times 1/5 equals 2/5. So that's my unit right there. Over here for my unit rate for cornmeal, 1, this becomes 5 times a half, which is going to be 5/2. So I have my unit rate for water. Here's my water one, and here's my unit rate for cornmeal. Han says I'm using 3 cups of water. I will need that much cornmeal. So that's his given is the water. That becomes our unit rate. So we're going to take this line, and we're going to take our 2.5, or 2/5, and we use 2/5 cup for every 1 cup of water. He has 3. So we're going to multiply it by the 3 cups that he has. That becomes 3 times 2 is 6/5. And I can write that as improper. 5 goes into 6 one time with 1 left over, so 1 1/5 cups of cornmeal. So that is correct. Good job there, Han. Tyler says I'm using 3 cups of cornmeal. So our given value is the cornmeal. So we find cornmeal at 1, and we're going to look at water. So our rate for water, our unit rate is 5/2 times 3 cups of cornmeal, which is 15/2. And 2 goes into 15 7 times with 1 left over, which is 7.5. So we have 7.5 cups of water, which matches what he says there. He's also right. So the reality is we agree with both of them. They took 2 different approaches to it, but they got the correct answer, and they're both going to input the perfect recipe. Good job. Number 4. A large art project requires enough paint to cover 1,750 square feet. Each gallon of paint can cover 350 square feet. Each square foot requires 1 350ths of a gallon of paint. Okay, so what do we know so far? Well, here's what we know. We know we have gallons of paint, and we have our square feet. I'll write it as SF. Okay, we know that a gallon of paint, so 1 gallon, can cover 350 square feet. We also know that 1 square foot can cover 1/350. Now how would you get that? Well, how would you go from 350 to 1? You would multiply by 1/350. So if you did it over here, what's 1 times 1/350? It's 1/350. So this is what information is provided to us in the problem. Andre thinks he should use the rate 1/350 gallons of paint per square foot to find out how much paint they need. Do you agree with Andre? Explain or show your reasoning. So the question is, if you want to find out how much paint they should use, which one of these would you use? Would you use the 1 350th, or would you use the 350? So which one of these terms would you use? That's the real question here. Andre thinks he should use this one, but you could also use that one. So it depends on what you're looking for, all right? So we know that they're giving us the square footage of the house. So to me, when they give you the square footage, it's probably easier to use what's been given there to help us figure that out there. But it really doesn't make a difference. Either one is going to be fine. We've seen it before. So if you take Andre's idea, he would do 1/350, and what he'd have to figure out is, well, I know that what my numbers are multiplied by, because I need to find out what the square footage is going to be. I'm going to multiply by the square footage, which is 1750. So 1750 divided by 350 is actually equal to 5. So that would tell him that he needs to actually use 5 gallons of paint. Is he right? Yes, he's right. Could he do it the other way? Sure, he could. So it's kind of a little funny problem the way they phrase it like that, but the idea is to say that you can actually solve it either way, right? Yeah, given based on what we're provided with here. Okay, so I think he's just fine. Yeah. Okay, number 5. Andre types 208 words in 4 minutes, so it's 208 words in 4 minutes. Noah types 342 words in 6 minutes. Who types faster? So to find out who types faster, you need to find out how many words they type in 1 minute, 1 minute. So to do that, this is 4 times 1/4, or 208 divided by 4 times 1/4. 4 goes in 208 52 times. And this becomes times 1/6. So 6 goes into 342 57 times. So for Andre, he types 52 words in 1 minute, and for Noah, he types 57 words in 1 minute. So Noah is typing faster. So Noah types faster. Good job, Noah. Number 6, a corn vendor at a farmer's market was selling a bag of 8 ears of corn for $2.56. Another vendor was selling 12 for $4.32. Which one is a better deal? Meaning which one is cheaper? So we have corn and we have money. And we have corn and we have money. So one is $8 for 8 corn for $2.56. The other is 12 corn for $4.32. So we want to really find out who has a better deal. That means who can sell me one piece of corn, 1 ear of corn for the cheapest amount. That's the idea. So to get to 1, we are multiplying by 1 over 8 over here, and over here we're multiplying by 1 over 12. So 2.56 divided by 8, or times 1/8, gets you 32 cents for 1 ear of corn, and 4.32 times 1/12, or 4.32 divided by 12, gets you 0.36. So who has the better deal? The better deal is our 8 ears of corn guy, because it costs 32 cents per ear with him. Alright, and the next one, our last one here today, it's multiple choice. My answer's on the back side. A soccer field is 100 meters long. What could its length be in yards? So how do we figure that out? And they gave us some numbers here, but let's not worry about the numbers. We know that meters is a greater measurement, 1 meter, than a yard. So if I have 100 of these, this number, because it's a smaller unit of measurement, should be a bigger number than what I have right there. So 100 meters is going to be the same as more than 100 yards, right? I should have something that's going to be 100 plus for an answer. So when I look at my answer choices, which ones are bigger than 100? Now again, remember, a meter is like this and a yard is like this, so it's not going to be a crazy big number. It's going to be, close, okay? So which one's over 100? Not 33, not 91, not the same. We would go with D, 109. All right, that's it for today. Have a great day, and we'll see you next time.